Okay, this is Jack Jackson. In the last video, we defined what we mean by independent events, and basically we found out that there were sort of 3 or 4 ways to look at it. We could say the probability of the intersection of A and B is probability of A times probability of B. That's not normally true, but if it is true, they're independent events. Or say another way, the only time you can just multiply the 2 probabilities to get the probability of the intersection is if those events are independent. It's also true that they're independent if the probability of A given B is the same as the probability of A, and it's also independent, A and B are independent if the probability of B given A is the probability of B. So basically what this is saying is that 2 events are independent events if and only if they do not affect each other. One has no effect on the probability of the other. So let's take that idea and look at some situations, and let's decide if these are actually independent events or dependent events. Of course, dependent would just be not independent. So suppose the events are drawing a blue ball from an urn on the first draw and drawing a red ball from the urn on the second draw if you put the ball back in. Do it with replacement. Are drawing a blue on the first and red on the second, are they independent events in that situation? And does it make any difference if we change it by saying draw a blue ball from an urn on the first draw and then draw a red from the second on the urn, but this time we do it without putting the ball back in? Which one of these 2 is independent, if either? Well, if you put the ball back in, then the probability of red on the second draw is the same as the probability of red on any draw. It's the same regardless of what color is drawn to begin with, so that's independent events. The probability does not depend on what happened earlier. However, as we've seen in earlier videos, drawing the red the second time, if you don't put it back, drawing that blue ball out the first time is changing the probability of the red the second time. The probability of the red on the second draw depends on what color was drawn on the first draw, so it's not the same on each draw, so those are dependent events. Okay, so let's look at a couple other real-world settings. Making an A on test 1 and making an A on test 2, are those independent? Flipping a coin and getting a heads with a fair coin on the 4th time and then flipping a heads the first 3 times, are those independent? Press pause if you need to think about this and then come up with some answers. Well, making an A on test 1 and making an A on test 2 are not independent. The probability that you make an A on test 2 is higher if the student made an A on test 1. So that is, those are not independent events. They are dependent. However, flipping a heads with a fair coin are independent events. So the probability of a heads is 1/2 every flip, regardless of what came before. So it doesn't matter if you did a heads the first 3 times or not. The probability of a heads on that 4th time is still 1/2. So that's independent events. Okay, are these independent or dependent? Making an A average on test and making an A average on homework. Okay, what do you think? How about rolling 5 on a die and rolling 5 on the other die when you're on an other die when rolling 5 dice? Okay, what do you think? Well, making an A average on test is actually higher if the student made an A average on the homework. So those are dependent events. Rolling a 5 on a die, rolling 5 on the other dice, I guess I should say, when rolling 5 dice is independent. Each die's outcome is uninfluenced by the outcome of the other dice. Okay, are these independent or dependent? Flipping heads on the 4th flip of a fair coin and flipping heads on the first 3 flips. Actually, we already did that one. and then having a boy on the third child and having 3 girls for the first 3 children. Okay, let's change this just slightly. So let's change the question to this. First situation is rolling a 6 on the 4th roll of a fair die and rolling a 6 on the first 3 rolls of the die. And then the other one should say having a boy on the 4th child and having 3 girls for the first 3 children. Are these independent or dependent? Well, these are both independent. If the die is fair, each roll is independent of earlier rolls. The probability of any particular roll being a 6 is 1/6 regardless of what the earlier results were. And similarly, the gender of each child is independent of the genders of earlier children. The probability of a boy is 1/2 each time regardless of what genders were of any previous siblings. Okay, how about a couple more? Choosing a student from an elementary school that can accurately reduce a fraction and choosing a 6th grader from that same school. And secondly, choosing a student with large shoe size and choosing a student with a high reading level. Are those events independent or dependent? Press pause if you need to think about it. Well, it's going to turn out that in both cases, these are not independent events. It's more likely that a 6th grader will be able to accurately reduce a fraction than a 1st grader. So the probability of being able to reduce a fraction giving a 6th grader is probably greater than the probability of being able to reduce a fraction chosen from the whole school. So being a 6th grader increases the probability of being able to reduce fractions. It's also true that shoe size, choosing a large shoe size and choosing a student with a high reading level is also not independence. Generally, students with larger shoe size will have a tendency to have a higher reading level. Notice that there's what we call a correlation here. However, this does not imply causality. In other words, it's not having large feet that causes better reading or better reading that causes larger feet. There's a hidden lurking variable that's causing both. It's age. As the age increases in elementary school, the shoe size tends to increase, as does general body size. And as the age increases, the students become more intellectually mature and have more training, more schooling, more education, thus increasing their reading level. So be careful to not assume that just because there's a positive correlation between two variables, in other words, increasing one variable tends to increase the other, don't assume that that means that there's a cause and effect relationship between the two variables. Okay, so even though these are dependent events, one does not necessarily cause the other.